Okay, welcome to Game Coding, Pygame Platformer Basics by Tokyo EdTech. That's me. This is probably one of the most requested things I get on my channel, and I finally had some time to work on it yesterday. And so I'm going to go ahead and try and walk you through what I did and how I did it and why. So first, let me give a quick shout out to my channel members. You can see Maud and Kim Xiong have made it to their second month of membership, so thank you so much. And thank you to everyone who has paid to be a member. I sincerely appreciate it. So let's take a look at what we're doing and what we have. So this is what I've already done, and I'm going to walk you through this in this particular lesson, but this is what we should have by the end of this. So you can see we've got some kind of platform stuff, and then we've got a player, and I'm using the arrow keys to move left and right. So each time I push it, the player moves a little bit. You can see how the player slows down because I added friction. And then the player will fall. If I push the space bar, the player will jump. And it jumps pretty realistically. I mean, it jumps really high. We probably wouldn't want that in a real game. But for a test, it's okay. And then if it falls off, it comes back to the top. So that's what I want to get started with today. So that'll teach you basically how a platformer works. So let's get started. Now, here is the platformer base code that we're going to start with. And it's just a very simple kind of skeleton code that has two things. Basically, it has a Pygame window, and it has a sprite class that I created. Okay, so you can see here, class sprite. Now, Pygame does have its own built-in sprite class. I haven't really done much with it, so I can't really say how to use it or how not to use it. But the sprite class that I'm using, what's nice about it is that it has just what we need, and it also would make this program easier to change, so that, for example, if you want to do it with a turtle, you could probably switch it over to a turtle very easy rather than using the Pygame sprite class. Okay, so just walk you through it real quick. I'm using the following modules: Pygame, sys, math, and random. In Pygame, you have to initialize the game. You have to initialize Pygame, I should say. And then you don't have to do this, but you can set your display caption. Now, there should be an underscore here, but sometimes it doesn't show up. So let's see. I'll make this text a little bit bigger so we do see the underscore. And I just gave it a name. And then we need a clock. And the clock helps us keep the game speed consistent between systems. So notice how this C is capitalized, everything else is lowercase. And I decided to make the game 1200 by 800 pixels. Notice how width and height are capitalized. I did that because these are constant values. They do not change. And then here I just defined a few colors that I might want to use. And as you can see from the demo, I'm using basically green, white, and black for the background. So we need to create a screen for Pygame. And we use pygame.display.setMode. And notice there's an extra set of parentheses here, width, comma, height. Okay, so that's a tuple. And as I mentioned earlier, I made my own sprite class. And when we initialize it, it has an x coordinate, a y coordinate, a width, and a height. And so then we just set self x to x, self y to y. We also are using dx and dy, which will control the x movement and will control the y movement. If you don't know what those are, I've done this in several other tutorials, so you might want to check some of those other things out. And of course, width and height are also added. Note, this is the width and height of each particular sprite. And by default, I've made each sprite white. The background is going to be black. And I've added a value called friction. And friction should be between 0, which is no friction, and 1, which is you can't move anywhere. It's like you're stuck in quicksand. Okay, so I just played around the numbers. 0.8 seemed good. You can make it whatever you want. I also made a little function for each sprite called goTo. And so I could say, sprite.goTo some xy coordinate, and it will go to that xy coordinate. And this is where we actually render, is where we draw what our sprite looks like. We use the pygame.draw.rect method, and we're using screen, which comes from here. We have a color, and again, we gave the color, initially we gave, basic sprites are all white. And then we use pygame.rect, and then we draw it at the X minus self width divided by 2, self y minus self height divided by 2. The reason is that in Pygame, the xy coordinates are the top left corner of that object. I personally don't like that. I find it a little confusing. So what I did was I have kind of like my own way of rendering. So from the center x and y, subtract half the width. That's this top left, and then draw from the width over. So you draw the width and the height. And this will just draw a rectangle or square or whatever shape we give it. Now later we could add, images and all that sort of thing. This is a very special method. This is called axis aligned bounding box collision. And this is what we're going to use to see if one sprite is colliding with another sprite. Now I got this from Stack Overflow, I think, some website somewhere. I mentioned this in another video I did. I had the link there, so I'm sorry I forgot what it was. And then here's just some comments that I may not necessarily use for this particular game. Tonight we won't do font or sounds, but we will do game objects. We have our main game loop, and this is just kind of standard Pygame stuff. For event in pygame.event get if the event type is Pygame quit, then we exit the game. And I'm looking for basically a key down, so we push a key down, and I'm looking for key left, key right. These are the arrow keys, and the space, and we'll be filling that in later. Then we got to move our objects, check for collisions. We have to do something if the player falls off the screen, render the background, render the objects again, and then flip, which actually puts it onto the screen. And then I set it to 30 frames per second for this particular game. You could set it to whatever you want, but 30 works well with the numbers that I'm going to be using. So if I run this, I have the following. So this is so far what I've got. So let's go ahead and start filling in the missing code. Okay, so we have some code to make a sprite. So what I want to do is I want to start with the player. Okay, so I'm going to make a new class called player, and it is a child of the sprite class. What that means that the player is also a sprite, so it inherits all of these different things from it. So when I instantiate my sprite, my player class, I need the init method. Again, if you know what this stuff means, watch my class and object-oriented programming tutorial. Explains it, I think, pretty well. So self, we need x, y, width, and height. And now because it's a child class, we also have to initialize the parent class. Now you can also use, super or something like that, but I like to do it pretty explicitly. So width, comma, height. I know somebody's going to ask me why I didn't do that. I prefer to do it this way. So our player is a sprite. And what I want to do is I'm just going to go ahead and create the player. So this is the player object. And I know this, one of the reasons I know this is because this is lowercase. This is uppercase. Class names are uppercase. So I want the player, and self is actually from here. That's a little confusing. So I need x, y, and the width. Now I've already gone through and calculated all these things. That's why I know what I'm about to write is correct. But it took me quite a lot of experimentation to get these things right. So 20 and 40. So let's go ahead and see what that does. Nothing, okay? Which is about what we expected. So I've created a player. I've put it at 600, 0. Now in Pygame, this is 0, 0. In the turtle, 0, 0 is at the center. So from 0 over to 600, because remember the width is 1200. So 600 would be the center, and it's at 0. So it should be kind of like half on the screen, half off. Now we don't see it because we haven't rendered it. So what I need to do is down here where it says render objects, I'm going to do player.render. And again, this render comes from the sprite class. And you can see this is that pygame.draw.rect thing I talked about earlier. Let's go ahead and run that. And you can see there is the player. Now the player is actually off the screen a little bit, so that's not the full player. I'm going to go ahead also and make the player green because I like that. So self.color green. Again, this green comes from here. I define the colors here. Let's go ahead and hit F5. Oops. And we got an error, which was tuple object is not callable. Self.color. Ah, duh. Okay, it's not a function. It is self.color equals green. My bad. Sorry about that. And now you can see it is green. Okay. So this is the part where we got to start thinking about how does a platformer work versus, say, like Pac-Man or Space Invaders or Pong. So what we're trying to do in this particular case is to simulate gravity. So we need to do the physics of this. So what I'm going to do is I'm going to, up here with width and height, I'm going to define gravity. Because gravity is going to be the same for every object. And basically, through experimentation, I found that one works really well. Now, again, keep in mind, Pygame is a little different to the turtle if you're used to my turtle tutorials. So this is 0, 0. Y is positive going down instead of negative, which is probably what you're used to or for math class. X is positive to the right and negative to the left. Y is positive going down and negative going up. So that's why gravity equals 1. Now, gravity affects the change in y. Okay, so if you're falling, gravity keeps adding speed, adding speed, adding speed, adding speed. So what I'm going to do is I'm going to make a new method here in my sprite class called move. And again, if you're not familiar with classes and object-oriented programming, watch my tutorial and come back to this. I'll try to remember to put a link there. So self-x equals, so plus equals self.dx. And self.y plus equals self.dy. And self.dy plus equals gravity. So what that means is dx and dy. So if dx is positive, it's going to move to the right. If dx is negative, it's going to move to the left. If dy is negative, it would move up. As we said, that's the way the y-coordinate works in Pygame. If it's positive, it will move down. So we're going to add gravity to that each time through because gravity is always acting on objects. So what I need to do is I've created this method, but I haven't called it. So here it says move and update objects. And actually, with this type of game, the order of the code is super duper duper important. If you put things in a slightly different order, collisions won't work correctly, and it gets very confusing. That's one of the challenges of a platformer. So what I'm going to just do here is I'm going to say player.move. And then that should do it. Let's try it. Okay, you can see the player just dropped right like a rock off the screen, which is what we wanted. Okay, and so the other thing I want to do is I'm going to border check the player. So if the player.x, y is greater than 600, so it's fallen off the screen, then we'll say player.goto, we'll go back to the start, 600, 0. Okay, so I'm going to hit F5, and it should just have an infinite falling loop. Falling, falling, falling. You can see how it's falling faster and faster and faster because gravity keeps working on it at high speeds. Okay, and we'll go ahead and stop that. That's getting a little crazy now. Alrighty. So we've got a player. The player falls. And so what we can do here is we could either do the left and right thing, or we could do the colliding with something thing. Let's go ahead and maybe just start with the collisions. It doesn't really matter what order we do this in. So let's go ahead and add a block. And what I'm going to do is I'm going to make a list of blocks because we're going to have more than one. Okay, And I'm going to go ahead and say blocks.append. And again, this is something I've already calculated, so I know, this is correct. So the block is just going to be a sprite. I'll probably create a block class later, but for now, this will do what we want it to do. 600, and I'm going to make it at 600, 200. It's going to be 400 wide and 20 pixels tall. I could have made it taller, I could have made it shorter, it doesn't really matter. Okay. So what I've done is I've created a block. It's a sprite at this X and Y location, this width, and this height. Okay. So then down here, it says move and update objects. Now, blocks don't move. They're going to be stationary, so I don't need to move them. But I do need to check for collisions. But first, let's see if it's on the screen. Not on the screen, because I forgot to render. So for block in blocks, block.render. Again, right now we only have one block, but we'll add some more. Okay, so what's supposed to happen is it's supposed to stop there. Okay, so collisions is very, very interesting. So what I need to do is I need to check for the player colliding with the block. So all of the blocks, I should say. So for block in blocks. Now this is actually the hardest part, at least in my mind, of the platform. This is what makes platformers difficult, is the math involved in the collisions. Now I've already told you about this collision method that I got off the internet. I don't quite understand it 100%. I know what an axis line bounding box is, but I haven't really sat down and done the actual math on this. I do have a video about collision detection, and if you watch that, it explains this a little bit better than I'm doing now. I don't want to repeat myself because I already have a video about this. So anyway, so for block and blocks, if player.is AABB collision with the block. So if the player collides with the block, I'm just going to go ahead for now and print collision. And the reason I'm doing this is I want to know, is this collision working? Is it registering? So I should see collision down here. So I'm going to go ahead and run it. Oops, and it's in the way. But you do see where it says collision. So that tells me probably it's working the way I want it to. Okay, so this is where you need to start thinking about how the collision is going to work. Okay, so if the block collides with the platform, in this case, or the block, what do we want it to do? And then this is the process I went through, and it took me quite some time to figure out all the exact math and the coordinates and how to do this. But it's a good exercise, and I'll walk you through some of it at least. So it's falling, it hits a platform, we want it to stop falling. So why don't we go ahead and code that? So we'll say player.dy equals 0. So that should stop the player. So let's see if it does it. Okay, there we go. It is stuck on the platform. So yeah, that's working. Amazingly enough. I didn't think it would work that well, but it did. There's some other code I have written here, but you'll see. So let's see here. All right, let's leave it at that. So why don't we go ahead and do jumping now, so we can see if it will jump. So again, we didn't have to do it in this order, but I think walking it through this step, you'll see how, okay, you fix this thing, and then it causes a problem over here with that thing. That's part of the challenge of coding, but also part of the fun. Okay, so let's go ahead and do jump. So here we've got keyboard events, and if we put the game, or we press a key, and the key is a space, we want to jump. So what I did was I just made it a player.jump method. I haven't made it yet, but I'm going to in a second. So in my player class, I'm going to say def jump self. Okay. Now think about this. If we jump, what are we affecting? Okay. We are affecting the rate at which the player is falling or moving or going up. Okay. So what I did So I said self.dy minus equals 24. And again, I just played around with the numbers. 24 seemed to work. So I'm going to go ahead and try this. Again, it's minus because in Pygame, minus moves you up. Okay, now I'm going to go ahead and press the space bar. And now we've got a jumping character. Pretty cool. That's pretty cool. It just looks cool. I really enjoy just doing this over and over again. Okay, so we got a jumping character. Now, I can tell you from experience, this is not quite done yet, but it looks good. So let's just move on to the next thing, which is left and right. Okay? And then once we do that, we'll add another platform, and then you'll start to see, okay, well, this isn't doing what I thought it should do. Okay, and this like I said, this is, I think, pretty educational for this type of game. I think it's good to see this because a lot of like game engines, you just type some code like, okay, platformer, player, it has it built in, all these types of things. And it's cool. It's great if you want to make a game. But if you want to learn how to code, yeah, it's not so helpful because they do so many things for you. So let's go ahead and do left and right. Okay, so just like jump, we're going to be making some methods. So def left, self. And instead of working on self.dy, we're going to be self.dx. And remember, left is also negative. And so I'm going to do negative equals 6. And again, this is a number I found worked pretty well. And so then that tells us right is going to be self.dx plus equals 6. Okay, so go ahead and hit F5. Now I'm going to hit the left arrow. I know what I didn't do. I didn't put that here. So player.left. So when I push the left arrow, I call the player left method. And this is going to be player.right. Okay, so there's left, and there's right. And the more I push it, the faster it falls. Now you can see right now how it's falling through the platform. So you can see there's a little bit of a problem there already. Okay. Okay, so let's go ahead and fix that. Now, what's happening is that, the player is falling faster and faster. So each time through the loop, instead of moving 1 pixel at a time, it's moving 6 pixels, it's moving 12 pixels, it's moving 20 pixels, whatever that speed is. So it jumps into the middle of the object. So to fix that, what we got to do is when there's a collision, where is that? So when there's a collision, we need to do something like the following. We need to set the dy to 0, but we also need to put that object up a little bit. Okay. And so what we got to do is say player.y equals. So we're looking at the block.y, okay, minus, because we're going up, block.height divided by 2.0 minus player.height divided by 2.0. Okay, so this is from the center of the block to the top of the block. And then this is from the center of the player to the middle, like basically to half the height of the player. And what that does, you'll see here, if I fall off, it puts it back up. So from here, it adds to here, and then it adds this distance. So half the height and half the height. So it puts it back to that particular spot. Okay, and you can see how it is working kind of like we expect, I think. Now the other thing is you got to keep hitting the left and right key. I'll maybe fix that in a future video, but for now it's fine. Okay, so jumping works. So what I'm gonna do is I'm gonna go ahead and it's looking good. So far I'm not seeing any problems. It's kind of doing what I want it to do. So I'm going to go ahead and add another block. And so I'm just going to go ahead and copy this. And I'm not sure what I used last time because that's the one part I didn't save well. So this one is also 600. Oops, it's also 600, but it's going to be a little bit lower, 400, and it's going to be 600 wide by 20 tall. Let me go ahead and run that and see what we got. Okay, so we got another, and okay, so it's working pretty well. Okay, I'm pretty happy with that. Let's let it fall off. Okay, so everything's still working. Now, let's see, I'm going to try and jump. Okay, good. And when you notice now, like it's going really, really fast. It's like skating on ice, which is fine if you like that. That's what I do. That's what I use the friction for. And so what we could do, and this is how I did it actually, is if there's a collision with a box, so player.dx times equals block.friction. And like I said, I set friction to 0.8. I kind of played around with it. Let me change that to 0.6 for now, just see what happens. Okay, so you can see how it's going and slowing down, stopping. Maybe 0.6 is a little too high. Oh, actually, it should be higher. Sorry. Higher is, like, lower is slower, is more friction. Yeah, sorry, I got that backwards. 1 would be 0 friction. 0 would be total friction. Sorry, I got that backwards. So I'm going to try 0.9. Okay, I like that a little bit better. Okay. All right, now, watch what happens if I jump. So you can see it goes right through the platform. Now, you may like that. If that is how you want the game to play, then by all means, leave it that way. So you saw how it kind of works there. I personally don't like that. Okay, so we have to deal with this particular situation. And the way we're going to do that is we're going to do some else statements. Okay. So think about this. We've got two cases. One where the player is falling from above, and one where the player is jumping from below. Okay. So here's how I dealt with this. I think there's other ways to do this, but I'm going to do it this way. So if there's a collision, okay, so I'm going to put here player is below. That's what we've already done. So if player.y is less than block.y, okay, because that's, again, that's the way the coordinate system works. Okay, it will do that. So let's go ahead and try that and see what happens. Okay, so that's still working. Okay, it's still doing that, which is not what we wanted, but that's okay, because we haven't dealt with the other situation. If player.y is greater than block.y. So in this case, so in this case, we are jumping up from below. So we're going to do the same thing. Player.dy equals 0. And I'm going to go ahead and just basically copy this, because we want to do the exact same thing, except in the opposite direction, because we're below. Okay, so now if I hit F5, I'm using Genie. Okay, now we got it doing exactly what we wanted to do. Isn't that cool? So we got a little platformer already. This is very much fun. Okay, I'm good with this. I'm really happy with where we're going. Okay, so the next step, I think, is to add some more blocks. And you'll see once we do this, you'll see that there's going to be some errors popping up with the way it behaves. Now, I'm just going to go ahead and copy it from over here because I forgot to write it down. And so these are the rest of the sprites that I did. Now, what I could do is I could just copy it the way it is. But I'll stick with what I did in the other video. So I'm going to copy that. And again, you know, feel free to make your own. So I'm going to go ahead, blocks.append. Okay, don't forget that second thing, blocks dot, and it doesn't matter what order you append these, it's going to work just fine. You can put them in whatever order. And blocks dot, oops, I forgot the blocks dot append. Okay, so I'm going to go ahead and run this. And there's what you saw earlier. Now, watch, you're going to start to see some weird little things happening. Okay, that's still working. That's fine. Okay, that's working. Now watch what happens when I hit from the left here. Did you see what happened there? Okay. Now, let me show you what's happening. I'll have to change something. I'm going to make this 800, so that's off the screen. So player Y is greater than 800. So you can see actually what happens. It fell right through. Okay, now you notice there it went up. Okay, I don't want that to happen either. I want it to bounce off, and I don't want it to like automatically shoot up. Okay, so what's happening is there's a collision, and we only have two cases so far. We have if it's above the halfway point or below the halfway point. If it's above, puts it up here. If it's below, it puts it down here, which is now below the platform. Okay, so that's why we're seeing that weird error. So we got to deal with that, and that's pretty straightforward to deal with. It's not too hard. But we got to add another another condition. So if player is above. So what we're going to do is before these, it has to be before. So if player.x is less than block.x minus block.width divided by 2.0. Again, it took me a while to figure this out. And, okay, well, I'll do it that. I'll leave that one. There's an and. We say player.dx equals 0 because we want it to stop moving left and right. We say player.x equals block.x minus block.width divided by 2.0 minus player.width divided by 2.0. And again, this is just the x-coordinate version of what we did here. Okay, so if it collides, we want it to move just outside of where the box is. So I'm going to make that a 0. So I'm going to test this. So this is a case where the player is to the left. Player is to the left. Okay, so I'm going to go ahead and run it. So the player is to the left. I'm going to go to the right. Okay, something went wrong there. Let me see what I did. This should be an elif. Okay, because we can only do one of these collisions at a time. Okay, so I'm going to go to the right. Oh, it still did it. Now, why is that? Layer.dx block width. 2.0 block x. Two point oh. It's moving to the right. Okay, let me just run that again, see what's going on here. Oops. Okay, it worked there. Okay, so that's doing what I want it to do, but if I'm down here, oh, okay, now it's not doing it. Okay, great. All right, maybe, yeah, okay, well, I'll chalk that up as a win for now. So it's working fine, but it might not be. There's something I got to fix, and I'll show that to you in a second. So I'm going to go ahead and do the exact opposite thing for moving to the right, or moving is to the right. So copy. So there's basically 4 cases. So the player is above, player is to the right, and player is to the left. Unless I missed one of those. So we're going to be greater than block x plus block width. And then same thing, we want to add, just like we did with the Y. Okay, so I'm going to go ahead and, oh, that was weird. Oh, okay, I know what's happened now. I remember how to fix that. Now you see how it's like doing that weird thing like that? So there's still a couple little weird, you saw what happened there, right? Oh, there's another weird thing we got to fix. So you see there's kind of some weird artifacts. Okay, so I know what's going on, and I'll fix it here. Again, I figured this all out yesterday when I was experimenting. One of the problems that we're having, and this was a really subtle thing, is that when the player is above, and then how can I put it? And then because down here then we do the movement, we do all the physics, there's still actually a collision registered. And so what we got to do, what fixes it, is to add 1 here. Or is it subtract 1? Yeah, it adds 1. Plus 1. And again, it just took me a really long time to... No, player is above, sorry. Sorry, it's going to be this one. Plus... Let me see here. So I'm just checking what I wrote before. Player is above, we add 1. Player is above. Yeah, so we add 1. Plus 1. So I think that fixes it. Okay, that didn't fix it. I think the other thing I had to do was for this thing, there's an extra and condition. So and player.dx is greater than 0. So if it's to the left and it's moving right, and then and player.dx is less than 0. Okay, so okay, so you see how it's still messing up over there, which is kind of annoying, but my other one doesn't do that. Why is that? Okay, that's working. And again, this is the process. I did this yesterday, and it worked. Didn't have this problem yesterday. I got to figure out why. Probably have a little error somewhere. Let's take a look at the code real quick. Okay, I'm just going to compare it to what I wrote yesterday, and I have it on a different screen here, so you guys can't see it. Player x is less than, so players to the left, block x minus block width divided by 2. Player dx greater than 0. Yep. Player dx equals 0. Okay, good. Player is to the right. You guys probably saw this a while ago. Okay, that's to be a plus, not a greater than. So I guess I didn't need all those things I was doing, but these things do fix all the different problems that you have with this type of game, except for that one. What did I do wrong there? Again, I need another elif. Again, you guys probably saw that. I think I did that yesterday too. Okay, there we go. Okay, it's off the screen. And you notice how it's slowing down when it's the friction thing. And now the other thing is, like, you notice how it's up in the air, which is not what we want to happen. So the way I fixed this one, and there's got to be a better way to do it, but I'll do what I just did last time, is before I jump, I'm only going to jump if there's a collision. Because you only want to jump if you're touching something. So you shouldn't be able to jump in the middle of the air. So if the player is touching one of the blocks, then it can jump. And then at that point we can say break, because we can stop searching. So we search through all the blocks. Is there a collision with the block? If so, then we let the player jump. So I can, okay. Aha. That's what I did. Okay. So that's why I screwed that thing up earlier. Okay, that makes sense. All right. So if you remember earlier, I was talking about this +1 thing, and that should fix that. I'm not sure why it's not, but that's the reason I added that +1. Let me check the code here. And that's players above. Player dy equals 0. Player y equals block y. Ooh. Okay, I think this is above. That's why I labeled it incorrectly. This is below. Sorry about that. So this should be here. Because what, yeah, let me just make sure that works, and then yeah, I'll stop talking. I don't know what I'm talking about. Now you notice how I do let it kind of move in the air a little bit. I don't know if that's the way you want it, but I kind of like that. I like that effect, so you can jump in the air. Okay, so basically what's happening is, before, what I was doing is I was putting the player up just above the platform. So in that case, there was no collision. But because of that, the jumping thing didn't work right. So what I did was I put the player up above the platform, but +1 pixel. So there is a collision registering right now. So that fixes that problem. It works pretty well, actually. Yeah, I think that's it. I think that's what I wanted to do in the game today. So that's your platformer. Yeah. I don't think I'm missing anything. Okay, that works. I can go back and forth. Now I did see how it goes a little too fast. I did add a little code to limit the speed. So in the player thing, so if self.dx I think is less than, I think I did -12, self.dx equals -12. So I kind of limit the maximum left and right speed. If self.dx is greater than 12. And again, I just played around with numbers until I got what I liked. You can do whatever numbers you like as well. And maybe make it, okay, so you can see that's the maximum speed it will go. And then you can see the friction is slowing it down. Okay, and yeah, that's it. So there is your platform game. Let me just go over that real quick again, just kind of review some of the main points. We're using gravity, and gravity is positive in this game because of the way Pygame's coordinate system works. Then we got some colors we defined, just basic Pygame type stuff. We have a sprite class, which I explained earlier in the video. And then the player is where we added a bunch of stuff. Okay, so we set the player's color to green. We initialize its parent class. And when the player moves, we add dx to its x, dy to its y, and gravity to the dy. So that's just physics. That's just the way physics works. When we jump, we change the dy to -24, or we subtract 24 from the dy, so it will go up. And then for left, same thing. We go left -6 from wherever it's going. Right is +6 on the dx, and then we limited that speed. We just added we added the player, we added some blocks, and you can kind of just design your own kind of thing at this point. Maybe in a future video we can add some images so it looks like an actual platformer. We'll talk about how to move the camera around a little bit. Then this is just the standard Pygame event loop and how we do things in Pygame. So we're looking for a key press, and if it's left arrow, move the player left, right arrow, move the player right. Space, we said, should only work if the player is basically landed on a block. And so here's all the code. So we move the player, and then for every block, we check for a collision. And then if there's a collision to the left, we set the player dx to 0, and we move it to the left of the block. If it's to the right, again, same thing. We check if there's a collision. We move it to the left or to the right of the block. And then the same thing with y, where the player is above the block. If it's falling, we set the dy to 0, and we set the height to just above the block, but 1 pixel in, so we have a little bit of an extra collision going on. And then if it's above, we activate friction. I didn't activate it here if the player's below. I didn't think it was really necessary because there should only be a momentary contact. But above, we want the friction to work. And remember, I said it wrong initially in the video, but the higher the friction number, the less friction there is. The lower the friction number, the more friction there is. And I could have reversed that, but since I'll leave it the way it is. And then, yeah, so there's 4 cases where the player is coming from the left, player's coming from the right, the player is falling, and the player is moving up from below. And they have to, if you notice how they have to be exclusive, so if and elifs. You see a couple times in the video I had if, and you can see it had those weird artifacts that we didn't want to happen. And then when the player, falls off the bottom of the screen, we just want to move the player back up to the beginning. Now we could also do something like, player.dx equals 0. So, and player.dy equals 0. So when it falls off the screen, it falls straight down. Now you might prefer that, you might not. I kind of like it that way myself. And then we just fill the background of the screen. We render the player, render the blocks, and we do the Pygame flip method. And then we, again, as I said in this particular game, I set the clock to 30 frames per second. If it was 60 frames per second, you'd probably have to reduce these numbers to match that. But these numbers work pretty well for the current size of things. So that is it. I will put this code. Oh, I should have saved the base version. Okay, I'll make a base version for you guys so you can kind of follow along, and I'll erase everything that I did here. And then I'll also put this in there for you in case you just want to download it and play around with it. Okay, so yeah, like I said, again, just quick thanks to my members for supporting the channel and encouraging me to produce more content. It really does make a difference. So if you can, click the join button below. Everybody else, have a great day and keep on coding.